Hi, everyone. So our guest today is Laura Bronner, who is Senior Data Scientist at the Immigration Lab at ETH Zurich. And before that, Quantitative Editor at FiveThirtyEight. If you've not heard of Dr. Bronner, then let me just say that now that Laura has left FiveThirtyEight, I don't read FiveThirtyEight. She's got a PhD in political science from London School of Economics and has this just killer skill of mix of like these stat skills, these communication skills, seriousness, but rigor. And it's all just grounded in this like real world applications. And it's just so rare that somebody has this mix. I suspect that in another life, she and I would be colleagues here at Toronto. And Laura, I would point out that we are hiring and that Toronto is a great school. It's wonderful to be an assistant professor here, and I think you'd really enjoy it. I'd like to do something slightly odd, and that's talk about her master's thesis. So this was actually published in the Legislative Studies Quarterly. In that, she looks at voting behavior of UK politicians from 1867 using roll call data and individual characteristics. So she brings all these like, sort of really cool data sets, super messy data sets, cleans them up, and then does really cool statistics to tell us something about the world that matters. More recently, an article that folks here might be interested in is why statistics don't capture the full extent of systemic bias in policing, and I'll put the link into the chat, and she wrote that for FiveThirtyEight. Laura was just a dream get as a guest, and I'm just so happy to be able to welcome her here to the Toronto Data Workshop, so thank you very much for joining us.
Thank you so much. That was super nice. I'm a little bit, off kilter now. All right, thank you so much. I feel free to break in with questions at any point. I guess I will screen share and we can get started. If I manage to share the correct thing, which I rarely do. All right. Okay. So this is a talk that's sort of about quantitative editing, but it sort of brings in my, at this point, many years of experience with data. So if there's any way to make this more sort of useful to you specifically, then please do ask. I don't promise that I'll have a good answer, but I do welcome the opportunity to try and, make this more directly relevant. Without knowing how to make it more relevant, I've just sort of put in a bunch of examples of my own work, but yeah, if I can help, please let me know. All right, so I am a senior applied scientist or a postdoc, in other words, at ETH in Zurich, Switzerland, although I'm currently based in Vienna. And I'm working on a Stop Hate Speech project, which is combines sort of causal inference-y stuff with NLP type stuff and a bunch of other things. And haven't really started yet, but I'm very excited about it. So maybe don't ask me too many questions about that, because that is like the one thing I cannot actually answer things on yet. Before that, I was a quantitative editor at FiveThirtyEight. And before that, I was a senior analyst at the Analyst Institute, where I was designing and running and analyzing experiments on the midterms in 2018. And before that, I did a PhD, which was also sort of quantitative texty and causal inference-y. So what does a quant editor do? Essentially, what I did was I reviewed code. Any analysis that was based on code, I generally looked at. I also sort of consulted with people on like what to do and how to do it and what, yeah, just generally sort of, the conversations that you have with your friends and or family members, I don't know, your life, about, research and how to make it better. I also talked to people, mostly journalists, about scientific papers. Like there are, a lot of journalism, especially science and political and social science journalism, is based on scientific papers, and a lot of those can be quite complicated. Obviously, I don't have a background in science, but when it came to quant stuff, I think it was helpful to have me around to sort of point out when maybe a regression table wasn't exactly providing the goods that like maybe the abstract promised or something like that. I also edited articles for like the strength of the evidence and like to make sure there was like a match between the data or the analysis and how it was described. And I also did sort of more classic data journalism where I like pitched articles and wrote them and talked to people and stuff. So that was also fun. I'm getting like an error when I try to, okay. So this talk is essentially has 3 parts. The first is like how to interrogate data. So like, what did I do as a quant editor? And I hope that this is sort of more generally relevant for people that work with data or work with people who work with data. And then sort of 2 directions to go in. One, if the data you have is good enough for what you're trying to do, and one when it is not. All right, so how do you interrogate data? So I mean, to step back a little bit, FiveThirtyEight is a data journalism site. So people generally use or include data when they're telling stories, but you know, data is flawed. And journalists work on shorter timeframes than a lot of researchers or academics do, as I am learning now that I'm back in the academic world. It's great. But obviously, so data has issues, and so it's very hard, and often they just don't have the background of like really trying to unpack those issues. So my job was, on the one hand, to make sure the data issues didn't compromise the story, and also to provide a bit of balance between like academic type rigor and accessibility. So what I would sometimes do is I would like run some more complicated analyses to make sure that what we're showing is actually real, but then we would just present like a difference in means. We didn't always present like confidence, like uncertainty estimates we sometimes did show, and I tried to make that a more, you know, a bigger part of what we were doing, but sometimes what I did was just more behind the scenes and trying to sort of balance between what an academic might want to read and what a non-academic might want to read. I mean, in general, the readers of FiveThirtyEight, there are some that are really going to read through all the footnotes and read all the methodology posts, and we want to provide stuff for them as well. But we also, I'm still saying we, sorry, they, but they also want to sort of provide a useful reading and an accessible reading experience to people that don't necessarily care about all the details and just want the takeaway. And the other thing, you know, I did was constructively try to shepherd stories onto safer footing. So try to steer them away from stuff that was maybe a little bit iffier and focus more on the stuff that I thought was sort of better. Okay, so there's no perfect data. I hope that you're with me on this one. So there are 2 options. Either it's good enough, in which case, you know, you understand its caveats, you make sure you don't overclaim, and you try to work with it as best you can. The other option is it's not good enough, in which case, you know, don't use it irresponsibly, but also you can try and see if you can make the issues with the data the story, or like try and turn that into an explanatory piece maybe about just why things are not going the way you want them to. So essentially my argument here is always that your data is really only relevant insofar as it matches your question. And so interrogating the data is, the idea here is to understand it so that you know if your question is the right one, or if your data is adequate to answer the question you're asking of it. What can and can't you say considering the data that you have? And what's key here is that, you know, this is often is working with quantitative data, but that requires qualitative understanding to answer these questions. And this is one place where like I was able to learn a lot from my colleagues. I mean, that sounded catty. I learned a lot from them in all sorts of ways. But they were basically qualitative experts, right? I mean, they're journalists, they're used to interviewing people, digging down sources, like all this stuff. They have had a lot of experience, much more experience than I did, because as you said, Rohan, my dissertation was on Victorian Britain, and I did not do a lot of interviewing of those sources. I can tell you that. So that was really useful and really let me, you know, and I also US data, which obviously is pretty much all FiveThirtyEight does, and sports data. So I had to rely on them to have this thick qualitative understanding of the data, which was often not what I was bringing to the table. So it was very much a collaborative approach to try and answer these questions. So, okay, how do you interrogate data? So where does the data come from? How is it collected? Was it scraped? Was it downloaded? Could there have been an error? somehow. For example, if you're scraping stuff that was put up over time, did the format change at some point? That's always a favorite. Could it be recollected in theory, or has something changed? There are, for example, some sort of averages that like smooth backwards. So like, you know, the number for a specific date will change depending on the next date. And so that sometimes messes with things, because then it depends on like with the date you're trying to get it from that site, even for a previous date. Not sure if I explained that reasonably. Who did it come from? Like, what was the organization that provided it? Was it a public poll? Was it a private company? Was it government data? Like, what were the ways in which, what was the thinking behind this? And is there a vested interest in showing one thing or another? And one question that was actually important more often than not is any part of it the output of a model? And if yes, then what goes into that model? So polls are, for example, something that you might not necessarily think are the output of a model, but a lot of US polls will have a likely voter model incorporated into them, because it's not just about who people say they'll vote for, but also how likely that person is to vote, which is generally a thing that pollsters model. And so that's often proprietary and not something that you can get your hands on, but it's important to be able to think about that as a source of potential error, for example, when you're looking at polling data. What do you know about the data? Why does something end up in your data set, right? Are there rules for inclusion or exclusion? So we did a lot in my first year about Democratic primary candidates. The first thing we did was we had to define a major Democratic primary candidate, because apparently 323 candidates filed for the Democratic primary at the FEC. So we were obviously not going to write about all of those people. So we had to, come up with criteria. There were some disagreements about whether these were appropriate criteria, but once we put them out there, we had to stick with them. But thinking about why something ends up in your data set is often like a good idea. Are you only looking at units, for example, with a certain outcome? Like if you're looking at highly successful people, or if you're looking at people with COVID that end up in a data set because they got a test or whatever, that censors your data set in a certain way, and that can matter for what you're seeing. Same with shooting, for example. If you're looking at sort of a data set of shooters, and you're trying to look at the variables that predict that, and you're missing the data set of non-shooters, then your conclusions are going to be skewed. Does it combine multiple sources? And if so, are they actually combinable? So these are here 3 definitions of the city of Atlanta: the metropolitan statistical area, the urbanized area, and the census place. These are obviously quite different. If you look at something like density, they will differ drastically across these 3 different measures. But also some things are recorded at one level, some things are recorded at another level. These are all in the census. So it's important to know and also to pick the appropriate definition for what you're doing. How is data processed? Was there any like recoding? Is there a record of all that? There were some differences of opinion at FiveThirtyEight regarding, statistical programs and how to process data. And so this idea of keeping a record of the ways in which you change your data was something that I tried to push commonly. Could things, if you're subsetting things, could that have induced bias? Was it merged with other data? All questions to ask. And don't be afraid to ask questions that might seem stupid. So like, why are they using something? Why are you combining these? Where does the data come from? Why are you including some things, not others? These are all questions that I think sometimes I felt, especially when it was something that I didn't know that much about, like football, I would feel like an idiot for asking these questions, but actually sometimes they do uncover things that are wrong, and that like even a person just has made certain decisions down the line and of data analysis, and actually, a naive person coming in and asking questions that they think are stupid might actually be helpful. So for example, if you're using the same thing, the idea of like a moderate voter, an independent voter, and an undecided voter, these things are sometimes used interchangeably to mean a voter that is like open to persuasion, for example. But if you look at surveys, these are actually different groups of people. Very few people describe themselves as all three of these, for example. So this is something that, like, it's just one example, but things to keep in mind. Okay, so let's say you've interrogated your data. You've decided that it's good enough for the question. So here's a bit of an example of how that might look. So I don't know if you're familiar with Martin Quinn's scores of Supreme Court justice ideology. So these are for Supreme Court justices, and they are essentially a model that it's like an ideal point of Supreme Court justice ideology. So here's these points for, I think, the most recent term with confidence intervals. So let me digress briefly and say that this is actually a good example of a chart in the way that 538 likes to do charts. And obviously, I think I had nothing to do with these charts. I think they're very beautiful, but they also do certain things, which I actually think are very good principles to keep in mind. One is they try to be self-sufficient. So if it gets shared without the article on social media, the idea is that you can read off the takeaway from the chart. You don't need the article for context. Obviously that does happen, but also I think, sometimes people just skim an article and just look at the charts, and it's good to be able to have that. So this is, so here you always have in the title of the chart, you have the takeaway. You have here, Roberts was likely the median justice. Note the word likely, which gets at the other point, which is that there's uncertainty. And what we tried to do here in particular was highlight the uncertainty of these estimates. The fact that there are confidence intervals and that these actually overlap for Roberts and Kavanaugh and Gorsuch, where it's unclear which of these, well, I mean, most likely Roberts was a median justice, but there is some uncertainty there. And then you also see that like the subtitle of the chart will essentially describe the data, be the most concise. And there's a lot of back and forth over this because you want to be concise, you want to be informative, but you also want to give people enough information to assess it. And then there are often annotations to point out the key takeaway. So those are sort of the three principles of a 538 chart, is like the title is the takeaway, the subtitle is the description of the data, and then there are annotations to point out what you should really be looking at. Anyway, so these scores are quite widely used in journalism especially, but also in, I think in academia as well. But there are some stringent assumptions underlying this. So for example, that the cases are the same or similar every year, which we know is not true, right? Because the Supreme Court decides what to rule on. And so if the Supreme Court changes an ideology, the things it chooses to rule on can also change. And in fact, they do change. And also it assumes that justices are similar every year, which again is not true. The composition of the court changes, and so these scores also change. And so after talking to a lot of academics and other people about this, we essentially figured that what we were more comfortable with was showing like the rank of justices on these things over time, or rank ordering justices in general, but not to use these scores, the cardinal positions, and track those over time. So for example, this is from the New York Times. The idea here is that, Republican nominated justices move left over time. And so they pick a bunch of well-known examples of this, but also John Roberts and also Kavanaugh and Gorsuch, and they argue that these justices are drifting left over time. As far as my understanding goes, this is not like a reasonable takeaway from this data. We've also done this. This is a 538 chart, also using these cardinal positions, which is also not great. So what we settled on is essentially this kind of approach where we use the ranking, and the takeaway of this chart, as you can tell from the title, is that Ginsburg's replacement could be the third largest shift on the court. And so, there are annotations to try and highlight the other two. And this is where we sort of landed with using these scores and trying to highlight the caveats as well. So for another case study in data usability, I'm going to try and go through this a little bit quickly, but essentially we did a whole project on COVID testing locations, and we had the hypothesis that there are racial and income discrepancies in access to COVID testing. And we had, commercial geographic data on testing locations. But it was kind of hard to actually do this analysis well, because to measure access, we're trying to, get at distance, but also at like how many other people are trying to access the same place as you, right? If you're in a city, you're probably going to be close to a testing site, but there are a lot of other people there as well. So we tried to take density into account. We could have looked at, site per person or whatever within counties, but county borders are porous. People can cross a county border to get tested. And so essentially we assumed that people went to the closest sites in proportion to how close they were. And then we assigned them to those closest sites. And then we checked how many people those sites had to serve. There's like, if you're actually interested in the nuts and bolts of this, there are like articles online about this. I'm not gonna, it's a bit complicated. But essentially we used census block groups, and then we estimated test site demand. And then we compared the need across different types of block groups. So first, the problem was defining the metric. There are a lot of different variables that we, could have looked at that are interesting: race, income, density, state, and also different dependent variables, distance, demand on test sites. So these were some of the really beautiful charts that I made. This is how you tell that I need the Viz team to tell me this is awful. I knew this was awful, don't worry. But this is, trying to get at this like demand by race and by state. I was essentially trying to untangle these different variables that we know are related. This is by income, here's income and race. I also tried to look at density. Like it's just there's a lot of stuff going into it. So essentially what we tried to do is focus on cities to control for density in some way. And we focused on comparing majority white, majority Black, and majority Hispanic census block groups, because we felt like that was a thing that is easier to understand than saying, something that is, 25% Black versus 12% Black. Like what is that? It's harder to sort of picture that or have a sense for what that means. And we also incorporated income into the analysis. There are also problems with the shapefiles we were using. This is Philadelphia. Here are some sites that were being calculated as being inside Philadelphia, but they were not, largely because the shapefiles we were using were not granular enough. So here's the not very granular shapefile in green that you can see, and these are two sites that are in Camden. Here is a comparison of these shapefiles, the blobby one, and then the one we ended up using. The blobby one obviously is not a very good both are not that great at representing New York, but the blobby one is significantly worse. And in fact, this had real implications for the site. So circled here is Harlem and Queens, the Bronx. I don't know. I've already forgotten New York, but essentially you can see that there are fewer sites because we were dropping a large part of the city into the water. The sites that were in that area were just being dropped. And so it was changing how we were estimating demand. Also, the way we defined urbanized area was a little bit challenging. This is the Miami urbanized area according to the census, but these were the block groups I was including because this was not the same thing. This was something that, it took a lot of trial and error. In the end, what we decided on was to include block groups where more than 50% of their area fell within the urbanized area. But there was obviously some amount of playing around with this. So this is just to I don't want to, depress you with all the stuff that depressed me during the course of this project, but there are a lot of decisions that go into this, and the data is never exactly what you want it to be. We were also told that duplicate locations that existed in the data at the beginning were intentional. We were then 4 days before publication told that they were not intentional and that we should drop them. So we re-estimated everything, having dropped them. Fortunately, it didn't change very much. Anyway, so the final product we have was this article about which cities had the biggest gaps in COVID testing access. And these are the maps we showed. So we broke out these cities into majority white and majority Black or Hispanic block groups and tried to show the demand on testing sites. And we also sort of had this overall comparison of these cities, showing the percentage difference in need that we estimated. We also wrote a separate methodology post with the details. As I mentioned, we do try to cater to the person who's going to click on all the footnotes. I was this person before I started working there, so I understand the urge. And then we tried to emphasize the caveats in the main piece. So the fact that demand, our main, metric of interest, was estimated rather than the fact that the location data we were using was not current or fully comprehensive. And we used maps to highlight different regions rather than specific addresses, and because we didn't want to direct people to a testing location that might not exist anymore or something like that. And really importantly, we triangulated this with on-the-ground reporting. So there were a lot of bylines on the article, and we actually talked to a lot of people in the cities that we were focusing on to try and make sure that the stuff we were saying was, backed up by stuff on the ground. We talked to a lot of people who were running these test sites or who were trying to open more of them in certain areas. And I think that this, again, was really one of the amazing things this was actually a collaboration with ABC. So we had some really, really good reporters this is their bread and butter. So that was really great. We also did some additional analyses. Anyway, so that was with all its problems, that was data that was good enough for what we were trying to do. So what about data that's not good enough? So early COVID-19 case data, I think, is like one of the very good examples of data that was just not good enough for what a lot of people wanted to do with it. Everyone was obviously interested in this data. It was very interesting, but it was also really, really flawed, right? There was not enough testing, and the availability and criteria differed and changed across time and place. And so any kind of comparison was just inherently fraught because of these problems. And there was a lot of reporting on this. So what we decided internally was essentially that we would obviously use this data for like descriptive reporting, and we would try to describe these caveats, but we also shouldn't try and do preliminary analyses like, do local lockdowns affect rates, or how do the political decisions made, because the testing itself was so political, and like the decisions on how to test and who to test and all this stuff was itself so influenced by all these decisions that it was just impossible to disentangle these things. And this is also an example of the thing that we tried to make the data the story. So can we take a step back and explain that the data is unusable, especially when it's a data set or source of data that a lot of people are using or wanting to use, like in this case. I mean, it's understandable. So what we did was we wrote an article about why it's so freaking hard to make a good COVID-19 model, in part because we were getting, believe it or not, emails asking us to make a COVID-19 model. And we're like, no, we can't do that. And then in trying to explain why that was, I tried to draw why, I mean, this is not my drawing, I cannot draw this nicely, but tried to explain why these things were so hard. And, a lot of it was because there were so many variables that went into this, all of which had a ton of uncertainty and a ton of measurement error. And the measurement error in part was correlated, but also sometimes not. And so it's just, all of this was incredibly hard to disentangle. We talked to a bunch of people who, confirmed to us that this was very, very hard. But essentially this was, I think, to my mind, a good sort of contribution at the time when a lot was going into, this precise model predicts this by this date, or this many deaths, or if we do X, then we will reduce the number of deaths by this amount. And I think that just reminding people how hard all of these predictions are because of just all these sources of uncertainty, I think was valuable. And also got turned into a comic, so that was very cool. That's a very cool thing. We also, so for another case study, we did something on police misconduct settlements. And here I want to also talk about just why this data was bad and how we decided to not end up writing a story the way that we wanted to. So we sent FOIA requests to 50 cities. We wanted to find out how much money do cities spend on police misconduct settlements, and has that amount changed over time? We asked for 10 years of data. and which cities are like better or worse than others. We were not able to answer these questions. And so we essentially wrote a story about why. So firstly, we didn't know if we were getting all the settlements. Cities had different definitions of what they sent us, for what they sent us. Many didn't provide any descriptions at all, or extremely vague categories. Some included like car accidents or slip and falls or employment settlements. Some had like traffic lights that fell on cars or stuff like that, or sewage overflow. Some just sent us court documents. One city actually sent us a PDF entitled Spreadsheet, which was a picture of a spreadsheet. And we asked for the spreadsheet and they were like, oh, we don't have a spreadsheet. So, there was lots of fun stuff like that. Some actually told us that relevant incidents might be missing. And there was just a lot of data entry discretion about how these incidents are categorized. And we realized that there was just no standardization. So even when two cities had the same category, so in this case, civil rights complaints or settlements existed in both Charleston and Cincinnati. But if you were, and in Cincinnati, it was a much greater share of the total number and of the amount. But if we wanted to say, oh, okay, maybe in Cincinnati, there are just more civil rights complaints, that's just not a conclusion that we could draw from this, because the other categories are so different, right? So like Charleston actually has a lot more categories, including some, like, for example, brutality or false arrest, which could maybe in Cincinnati be included as a civil rights case, right? Cincinnati also has the great category litigation. What does that mean? No idea. So these things are just not A, comparable with each other, even when they have the same name, and B, like, you don't actually get that much information from these. So in short, we decided that we just were not able to track, to compare between cities or even within the same city across time, because the person entering the data in 2011 might not be the same person as the one entering the data in 2015. And what they decide to categorize as a civil rights case, as opposed to a false arrest case, for example, could have just changed. Even the same person, I mean, come on. Do you categorize things the same way as you did like even 3 days ago? I mean, I certainly don't. Also, even if we had all the settlement amounts, it's kind of unclear what an increase or decrease in settlements or payouts actually means. So here's Cleveland. You can see the total amount paid out kind of increases over time somewhat, but it's unclear whether that means that, like, is the police committing more misconduct? Or does that mean that, like, victims or families of victims are more likely to sue? Does that mean that there are civil rights lawyers that are more willing to take the case? Does that mean that, juries might be more inclined to award damages, and so therefore cities are more inclined to settle before it gets to that point? There's just so many factors that go into these decisions that it's impossible to take an increase or decrease in number or amount and say that means X about how the actual misconduct works. I actually internally drew a similarly complicated diagram that I really wanted to put up, like, for the model, the COVID model, but people didn't think it was as interesting, so it did not see the light of day. I kind of agree in retrospect, but I was just trying to show just how complicated how many variables go into all of these decisions. So what we ended up producing was something like an article on the amount that cities spend. We had, a table where we showed the number of years that we got data for and the amount of money that we had, and then the, yearly average. But we also just went into quite a lot of detail on why this data is really flawed and why the analysis here is so hard and why this is part of an accountability problem that is, kind of key to how all of this works. And we put everything on GitHub and we explained all the problems that we had and the whole process we went through. We had, our pre-processing code that we put up explaining our decisions, because we want this to be useful. I mean, we have 31 cities that sent us usable data. It would be great if other people built on this, right? Like maybe local reporters or someone else. But we didn't provide it in an easy to use, pre-collated data set, because we didn't want people to just one-click download and then do some kind of a cross-city comparison, because we specifically didn't think it was reasonable to do that. We also, described our fun exchanges with various bureaucrats that we had. In DC, for example, I think we were sent 3 or 4 different files that were partially overlapping, unclear. We asked why there were differences, and they essentially told us they were running slightly different searches every time, because like each person responded to our FOIA in a different way. And so, yeah, sometimes this is included, sometimes it's not. So we just, put the one up that was the most complete from our vantage point. In Richmond, we actually only got 4 misconduct cases initially. And it was weird because Richmond is quite big and we thought there would be more. And so we reached out to a bunch of lawyers and they were all like, yeah, there's definitely more than 4, but none of them could provide us with like specifics. And so we're like, maybe there are only 4. Like, like I said, maybe there's others, maybe people just don't sue in Richmond or something. But then after we reached out several times for follow-up questions, the city eventually sent us cases of which 6 were misconduct. We asked them why they had missed them. And they were like, oh, it was in a different database that we didn't initially check. We had to check both of them and then compare the 2 to end up giving you this final set. We then asked them why they think that Richmond has fewer misconduct settlements than comparably sized cities. And they said that they were not sure. And if anyone has looked into this question, they are unaware of it. So great. So, and then what we tried to do was like maybe explain why all of these issues exist in the data and why this prevents us from using the data in a more straightforward way. So for example, there's, polling non-response that can drive polling fluctuations. So there was an article we wrote that was about that, and tried to unpack sort of how polling averages can change. If the process that produces the data is biased, so this is the article that Rohan referred to earlier, so the Y statistics don't capture the full extent of systemic bias in policing. So this this was based on an academic paper, but essentially tried to understand why we end up with weird samples, or why the data that ends up in our sample can reflect a biased process already and therefore hide the full extent of bias. The article this is based on is really, really good, but we were just trying to make this more accessible, especially at a time when a lot of people were using this kind of data to make claims about racial disparities in policing. And we just wanted to show that even when you're bringing data to this question, the data still is also a result of this bias process. Anyway, I will stop there. Thank you very much for listening. Please ask me questions or tell me I'm wrong, but be nice about it. And thank you for having me.
Laura, this was fantastic. Thank you so much for sharing with all of us. I can imagine it's a huge responsibility to know from the get-go that a lot of your work is going to be seen by huge amounts of people. They might not always have the expertise or the skills to really understand what could go wrong. So seeing this backstage process is really, I think it really, it's obviously very rigorous, but I think it also speaks very clearly to the legitimacy, not only of FiveThirtyEight, of course, but your own work now back in academia. Building that skill of pointing out what is not quite right, what could be better, what should be better, right? Like honoring that responsibility and be clear, what I keep finding, even in uncertainty, rather than trying to make crazy claims. So thank you so much. We'll start with the questions that we had sent you already. That's okay. We'll record those and people, please share in the chat any questions. The very first one is, what are some books that you recommend everyone read?
Oh no,
it's a bit of homework.
I should have prepared better for that. I actually only read fiction now. I don't know if I should admit this.
That you recommend?
Well, I'm trying to get back into reading German because I've been away from Austria for 13 years, and so I'm trying to teach myself German again. It's going great, but yeah, I will get back to you on the books.
No problem.
I guess I need to recommend, mostly harmless econometrics.
Okay. Making note of that.
I feel like that, yeah. Anyway, we'll see. I will get back to you.
Sounds great. And how about our second question, which was, how do we do a better job of integrating writing skills into quantitative PhDs?
That's a really good question. I think that one thing, I don't know, I think that I sort of had, during my PhD, it was like quite quantitative, and it was kind of a, I think I fell prey to this thing, which I think a lot of people in academia do, which is like sort of to make things more obscure and to make things more complicated sounding and to make things more, you know, to always be doing the newest method. And, you know, and in part, that's a question of people are definitely going to be asking you about all these robustness checks. And so you have to have an answer for them. But I think that, you know, being at 538 really encouraged me to think about things to think about like the trade-off with accessibility and to make things actually readable to people and to make them enjoy reading it. And I think this idea of like trying to capture the reader, I mean, I don't know, I haven't actually written academics since I started at 538, but I hope that I will take this lesson with me back into academia to try and, you know, actually make it an engaging experience, which is sort of anathema, I think, to a lot of, because it's just not how academic writing works. I mean, I remember doing it, and it's like you're trying to tick these boxes of like what a paper sounds like, and it doesn't sound necessarily fun, but, you know, it's nicer to read. I don't know. I wish there was like, maybe, I don't know, to incorporate it into PhDs, like maybe to try and summarize your findings in an engaging way, or to try and, you know, give your elevator pitch, stuff like that, to try and make sure that you have a version of your papers that people will actually listen to the whole thing of. I don't know.
I think that's super appreciated. I feel someone once told me that, you know, if you read the first paragraph and you don't understand it, read it again. If you don't understand it, that's on the author. So I think those skills in academia don't seem to always be applied or enforced, but I think that would be a great change. Thank you so much. So maybe we can stop recording.